Hi everyone, glad to see you again. In this video, we are going to talk about session 3.2, the metric prefix. This subsession covers two topics. The first part explains how the metric prefix works. The metric prefix is a prefix attached in front of the units of physical quantities or measurements. The second part gives an example of how to use the metric prefix to describe the events happening in different orders of magnitude in time. To understand how the metric prefix works, we first provide an example. You must have heard of PM2.5. It is a kind of tiny pollutant particle of size 0.000025 meters, which is 2.5 times 10 to the power of minus 6 meters. The size itself is a physical quantity and is composed of the number and the unit part. 2.5 times 10 to the power of minus 6 is the number part, while meter is the unit part. This is a very long expression to read. There is a more efficient way to express such a small physical quantity by calling it 2.5 micrometers. We can also represent the micrometer by μm. In such expressions, the order of magnitude 10 to the power of minus 6 in the number part is replaced by the prefix micro attached in front of the unit, such that the meter becomes micrometer, and only 2.5 remains in the number part. The prefix micro can also be symbolized by the Greek letter mu, so the unit becomes μm. The prefix micro or mu to the unit part is called the metric prefix because it is a prefix and is related to the powers of 10. If a prefix is related to the powers of 2, we call it a binary prefix, like what we use for the storage size of a computer. It is not the case that every order of magnitude corresponds to a specific metric prefix. Actually, for large and small numbers, every 3 orders of magnitude correspond to a new metric prefix, as shown in this table. Let's look into the detail. The order of magnitude 10 to the power of 3 is 1,000. The corresponding metric prefix is kilo, abbreviated by K. For example, 1,000 meters is 1 kilometer. The orders of magnitude between 10 to the power of 3 and 10 to the power of 5 are counted by units of kilo. The next metric prefix is mega, abbreviated by capital M. It describes the order of magnitude 10 to the power of 6, which is a million. The orders of magnitude between 10 to the power of 6 and 10 to the power of 8 are counted by units of mega. For example, we can call the distance of a star 10 million light years away from Earth 10 mega light years. The next metric prefix is giga, abbreviated by capital G. It describes 10 to the power of 9. Numbers as large as 10 to the power of 12 are represented by the metric prefix tera, or its shorthand capital T. Numbers of 10 to the power of 15 are expressed by peta, abbreviated by capital P. These are the most commonly used metric prefixes for large numbers. Let's turn to the metric prefix for small numbers. We can start from 10 to the power of minus 2 or 0.01. It is represented by centi. For example, 0.01 meter is 1 centimeter. Next order of magnitude is 10 to the power of minus 3, represented by the metric prefix milli, symbolized by lowercase m. For example, 0.001 meter is called 1 millimeter. The numbers as small as 10 to the power of minus 6 is called micro. The abbreviation is the Greek letter mu. For 10 to the power of minus 6 to 10 to the power of minus 4, the numbers are counted by units of micro, such as the pollutant particulate matter PM2.5 size, 2.5 micrometers. For small numbers of order 10 to the power of minus 9, we express them by the metric prefix nano, or its shorthand lowercase n. The term nanotechnology also has its origin here, as it means the technology at the length scale of nanometers. For even smaller numbers, 10 to the power of 12 is represented by pico, or lowercase p, while 10 to the power of 15 is symbolized by femto, or the lowercase f. There are metric prefixes for even smaller order of magnitude, but they are rarely used. You can find it out by yourself. We had completed the introduction of the metric prefix. In the following, I would like to provide you an example and show you how to describe events on various time scales by using metric prefix. First, let's look at short events. A typical blink of human eyes takes 0.35 seconds. One flap of hummingbird wings takes around 0.02 seconds, which is 20 milliseconds. Gear switch of the seamless gearbox on the Formula One car takes only a few milliseconds, much faster than you blink your eyes. The discrepancy in the time of the GPS satellite per day due to the effect of Einstein's general relativity is 38 microseconds. The GPS system has to correct this time discrepancy, otherwise the errors in global positions would accumulate at a rate of about 10 kilometers per day. The 10 MHz short radio waves complete one cycle within 10 to the power of minus 7 seconds, which is 100 nanoseconds. The GPS time accuracy is around 30 nanoseconds, and the cycle time for 2.5 GHz CPU is 0.4 nanoseconds. Next, let's look at the long events. One typical breath cycle of human adults takes about 4 seconds. The world record of 200-meter butterfly swimming, created by Michael Phelps, is 111.51 seconds. A 15-minute class session is 3,000 seconds, or 3 kiloseconds. A day takes 86,400 seconds, which is 86.4 kiloseconds. One complete lunar cycle is around 2.5 megaseconds. The entire human pregnancy takes 24.2 megaseconds, which is a bit less than 10 months. The average human lifespan is 2.2 gigaseconds, and a millennium contains 31.6 gigaseconds, which is 1,000 years. Do you know how long the age of our universe is? The answer is 13.7 billion years, which equals to 4.32 times 10 to the power of 17 seconds, or 432 petaseconds. Finally, as a practice of using the metric prefix, please answer this question. Please try to express your age in seconds and express it by the metric prefix. We also have two questions for your group discussion. The first question is, could you make an order of magnitude in length scale and an order of magnitude in mass scale, like what we did for the order of magnitude in time timeline? The second question is, can you find out the meaning of a digit, a numeral, and a number, and tell the difference among them? Thank you very much for watching the subsession of metric prefix. We will switch to the topic of mathematical expressions in the following session. We will start this new topic by dealing with the mathematical relations in the next video. See you later.